humans have successfully landed on the lunar surface 6 times using technology from the 1960s. The last crewed mission to the moon was Apollo 17 in 1972, and we've not been back in over 50 years. But a big new discovery is about to change everything as humans prepare to go back to the moon. The Artemis program is a US government-funded spaceflight program that will land the first woman and the next man on the moon by the year 2024. With it begins a new generation of lunar exploration and the beginning of Artemis Base Camp, which could be built on the moon by 2028. A possible site for the lunar base is Shackleton Crater, which is more than 12 miles wide and 2 miles deep, about as deep as the Earth's oceans. Imagine a massive lunar base inside the dark shadow of this crater. So why build a lunar base, and what would it be used for? The moon is a treasure chest of valuable resources like gold, platinum, and other rare earth metals. But that's not all. Water is a valuable resource when it comes to any kind of off-world exploration. If you split water into hydrogen and oxygen, and then liquefy the two, you have rocket fuel. A spacecraft from Earth could refuel in the moon's orbit or the lunar base. Scientists think there may be water ice in the bottom of Shackleton Crater, but there may be none at all. The Artemis missions will answer this question once and for all. If there is water ice in the crater, then it could be possible to use it as a resource. But water ice has been found in many other places on the moon, and NASA says there could be 600 million to 1 billion metric tons of lunar ice to harvest. If it could be mined effectively, the moon would become an interplanetary gas station for trips to Mars. But there are many things that need to be done before we can build our lunar base. The Artemis program has 4 main components: the Space Launch System rocket, the most powerful rocket ever built, and the Orion spacecraft, a lunar gateway that will continuously orbit the moon, and the Human Landing System, which will send astronauts to the surface. All these systems will operate together, and early Artemis missions will focus on testing all the components. If all goes well, we could be landing humans on the moon by 2024. These are 3 missions in the first phase. Artemis 1 will be a test flight of the SLS rocket and the Orion spacecraft with no crew. The mission is slated to fly at November 2021. The primary goal of the mission is to make sure the spacecraft is safe for astronauts. It will also carry 13 small satellites that will perform their own science and technology investigations. The Artemis 2 mission, scheduled for 2022, will be the first crewed flight test. This mission will test whether Orion's critical life support systems are ready to sustain astronauts on longer duration missions in the future. It will take 4 astronauts bound for the lunar orbit. They will spend 4 days orbiting the moon and then head back home. This mission will be the final preparation for the all-important Artemis 3, which will then land humans on the lunar surface in 2024. The Space Launch System has been under development since 2011, when it was first announced by NASA as its future rocket for deep space explorations. It's the most powerful rocket ever built, and when operational, will be the most capable super heavy lift vehicle in the world. The SLS has 4 Aerojet Rocketdyne RS-25 engines in its core stage, and 2 expandable Block 1 and Block 1B solid rocket boosters. The rocket's upper stage, the part that puts the rocket's payload into orbit and towards its destination, is powered by the interim cryogenic propulsion stage, which is a modified second stage used in the current version of the Delta IV rockets. An additional exploration upper stage can be added for sending payloads beyond the low Earth orbit. At 364 feet, it's slightly taller than the Saturn V rocket that took humans to the moon for the first time, and it's a strong rocket. The SLS is capable of delivering over 130 tons or 286,600 pounds of payload to a low Earth orbit. Space Launch System's Block 1 rockets will launch the first few Artemis missions. It will then be upgraded to Block 1B and eventually Block 2, which will be able to take the Orion spacecraft directly to the moon in a single launch and possibly beyond. The Orion Multipurpose Crew Vehicle, or MCV, is going to be NASA's crewed spacecraft to explore deep space. For the Artemis program, it'll be the primary crew transport to the moon, and also planned to be used for missions to Mars. Built by Lockheed Martin Corporation, the Orion MCV consists of the crew capsule, the service module, and the launch abort system. The crew capsule command module is designed to carry a maximum of 6 astronauts, but will only carry 4 on regular missions. It'll be the only part of the Orion MCV that will return to Earth. Attached to it will be the European Service Module, designed by Airbus Defence and Space. It'll serve as the primary power and propulsion component of the spacecraft until discarded at the end of each mission. And finally, since the entire orbit spacecraft is sitting on top of a rocket, which is pretty much a giant bomb with a nozzle, there'll be a launch abort system that sits on top of the crew capsule. In case of any accidents during ascent, it can fire its rocket motors and quickly eject the crew capsule away from the main rocket. It's basically an ejection seat for the Orion crew capsule if the worst were ever to happen. During a normal mission, after Orion separates from the SLS outside Earth's atmosphere, it'll fire up its single AJ-10 hypergonic rocket engine and put itself into a lunar orbit. Orion can stay in space 21 days undocked and up to 6 months docked. The Gateway is a critical component of the Artemis program and acts as a staging point for lunar surface exploration and eventually deep space missions as well. Once completed, it'll be a fully functioning lunar space station with its own propulsion unit, solar-powered communication hub, science laboratory, habitation units, and docking ports for spacecraft, payload modules, and landers. It will operate as a crew transfer facility, research platform, payload warehouse, and a command center for all lunar missions. The Lunar Gateway is a joint project between NASA, the Canadian Space Agency, the European Space Agency, and the Japanese Aerospace Exploration Agency. The first piece of the 55-ton outpost, its power and propulsion element, is scheduled to go into space in 2022. The habitation and logistics outpost will be assembled on Earth and sent into lunar orbit by 2023. More modules will continue to be added, including a robotic arm, logistics module, various airlocks for spacecraft, and a sample return vehicle. The Lunar Gateway will be considerably smaller in size than the International Space Station, having just 13% of the ISS's total pressurized volume, which has space equivalent to a comfortable 5-bedroom house. But Lunar Gateway's habitable volume will be like living in a recreational vehicle. That's why, unlike the ISS, the Gateway will not be crewed continuously, but it'll be inhabited at least once a year. An artificial intelligence-based robotic system, Canadarm3, will be able to tend to the Gateway when no humans are on board, including operating science experiments on the lunar outpost. Speaking of outpost, there has to be a way to get the astronauts down from the Gateway to the lunar surface. That brings us to the last part of the Artemis program, the Human Landing System. This system features an integrated lander vehicle that has the ability to go back and forth from the Moon's orbit and land humans on the Moon. NASA has selected 3 US companies to design and build human landing systems for the Artemis program. This means that all 3 systems will be used. Blue Origin will have a 3-stage craft called the Integrated Lander Vehicle. It'll be launched on its own New Glenn rocket system and ULA Vulcan launch system. A US company, Dynetics Corporation, is developing the Dynetics Human Landing System, a single structure providing ascent and descent capabilities that will launch on the ULA's Vulcan launch system. And finally, SpaceX and their Starship Lunar Lander, which is a modified Starship currently under testing. It will launch on the Starship Super Heavy. The entire cost of these 3 contracts are estimated at $968 million, and they'll form the backbone for the upcoming Artemis missions. Each lander has different capabilities when it comes to payload carrying capacity, getting on and off the lunar surface, mission duration, and survivability. After Phase 1 is completed, the second phase of the Artemis program after 2024 will focus on sustainable regular exploration of the Moon. In this phase, the Lunar Gateway will be used to conduct research and allow astronauts to take trips down to the surface. Science experiments in the field of human physiology, space biology, astrophysics, heliophysics, and planetary science will begin during this phase. Once on the lunar surface, NASA and its partners will develop the Artemis Base Camp to support longer expeditions on the surface. NASA is building a lunar rover called Volatiles Investigating Polar Exploration Rover, VIPER, that will land at the south pole of the Moon in late 2023 and will begin a 100-day mission looking for water ice and help us figure out how to harvest the moon's resources to further human space exploration. The Artemis program will incrementally build up the capabilities on the moon from that moment on. This will be the first step in preparing for the human exploration of Mars. If all goes according to plan with the Artemis program, perhaps we'll see a fully functioning lunar base within the next decade. We don't know about you, but we think that's really exciting, and will be amazing to see it all unfold. For the last 20 years, humans have continuously lived and worked aboard the International Space Station above Earth, preparing for the day we move further into the solar system